Hello everyone, welcome back to another informative video. In this video, I basically want to talk about just a few things pertaining to a previous video that I did. Now, if you can recall a video I did about the nitrogen cycle. So if you haven't watched the video on nitrogen cycle, please go and watch that one first before you watch this one. I think there are a few things to really set straight about the nitrogen cycle, and I'm basically going to discuss a few of them now. Of course, we have to understand that the nitrogen cycle is just one way of providing nitrogen to the soil environment, or in other words, to provide nitrogen for your plants. But what are the other ways of adding nitrogen to your soil? One of the most common method is by using synthetic fertilizer. Many of us can attest to that because we often go to the farm store and we buy our granular or our soluble synthetic fertilizers to add nitrogen to our soil. Fertilizers such as urea, right? Such as ammonium phosphate, ammonium sulfate, those kind of nitrogen fertilizers, and we use those to, maybe sprinkle around our plants or like rotivate into our soil and so on to add nitrogen. And then, of course, you have the more what we would say organic way of using our compost or our animal manure that is rich in nitrogen. And of course, chicken manure is very rich in nitrogen. And of course, we have also the method of the rain falling, because when the rain falls, it also adds nitrogen to the soil, right? So those are basically some of the other ways other than the nitrogen cycle. So I just wanted to get that clear. Now, another thing that we need to understand is that when nitrogen from the atmosphere, and remember nitrogen in the atmosphere, if you have watched the previous video about the nitrogen cycle, nitrogen in the atmosphere exists as a gas. It exists as N2, and it takes up roughly about 78% of the atmosphere, right? But the plant cannot use it as it is in the atmosphere as a gas. So what happens through the nitrogen cycle, it goes into the soil as a gas. It is worked on by certain bacteria and converted into usable forms, such as NH4, which is ammonium, right? And then it also is converted into NO3, which would be basically nitrate, right? So what happened is NH4 is basically a cation. I want us to please listen to this carefully. NH4 is, so we call it NH4 plus, right? It's when you see the plus, it is basically a cation, and when you see minus, it is an anion. So NH4 is a cation, and NO3, which is a nitrate, is an anion. So it is NO3 minus, right? Now, what I want you to understand about these two forms that the nitrogen is converted into within the soil by bacteria is that these two forms, NH4 plus and NO3 minus, they act very differently. Essentially, the plant can use both NH4 plus and NO3, but what we need to understand is that NO3 is more mobile than NH4 plus. Let me say that again. NO3 minus, which is the anion, is more mobile within the soil than NH4 plus, which is the cation. Now, why is this so? Why is NO3 minus more mobile than NH4 plus? Well, some of you may know, and for those who don't know, the soil is basically negatively charged, right? It is negatively charged. And what happens is, like repel and opposite attract. So the fact that the soil is negatively charged and the NO3 minus, which is the anion, is negatively charged, they basically repel each other. So they don't join to each other. They don't combine, right? So you find that the soil doesn't hold on to nitrates because it is repelling. So that is why nitrate is easily leach out or percolate out through your soil with soil water in solution. So you find that you will readily lose your nitrate. Also, you find that nitrate, which is NO3 minus, is also more readily absorbed by the plants because it is so freely moving in the root zone in the soil. It is easily taken up, quickly taken up by the plant, and it is also quickly lost through leaching and so on. Now, what you also need to know is that NH4 is not so mobile as NO3 minus. Reason being, remember I told you that like repel and opposite attract. So the fact that NH4 plus is a cation and the soil is negatively charged, so anion, then both of them will attract. So the soil will attract, which is negatively charged, will be attracted to the NH4, the ammonium, because the NH4 is positively charged. So they will attract. So you find that the soil readily holds on to NH4, right? It holds on to NH4, so NH4 is not so easily, it is not so mobile within the soil, right? So when the nitrogen gas comes into the soil, wherever it comes in and it is converted to NH4, it tends to want to kind of stay there, as I said, because it is very attracted to soil particles because of the anion and the cation attractability, right? So you find that unless a gradient is created, like a water potential gradient, where the NH4 can now move from where it is via movement with water into the root zone that the plant can take up the NH4. So you find that you'll have your plant roots here, and then the NH4 is here, and because it is a cation, the soil holds on to it tightly, and then when a gradient now is provided, like a water potential gradient, right? The water will flow to the root zone, and it will carry the salts, the ammonium with it to the root zone, and the plant roots can take it up. Or the plant roots will grow towards, because that is essentially what happens also. Nutrients will end up going towards the root zone due to a number of actions, capillary action being one of them. Or the root roots will basically extend into the soil and go towards where the nutrients are. So I just want you to understand that, and this is because NH4, as I said, is not very mobile in the soil as NO3. NO3 is very mobile, so it basically moves freely within the soil. If it comes here, it can go anywhere, right? But NH4 basically is latched on to soil particles wherever it is, and then based on the movement of water and so on. And osmosis also can allow movement of the ammonium towards the root zone as well. And also, before I go, there's this one last thing. Remember, in the nitrogen cycle, I was telling you that at the end of the cycle, the nitrogen is basically it is converted back into N2, which basically is a gas that escapes into the atmosphere, and then the cycle starts over. And it also converts also to another gas called N2O, which is nitrous oxide. Now, nitrous oxide is basically a gas that is harmful to the atmosphere. It will destroy the ozone layer, and we all know that the ozone layer help to protect us from ultraviolet rays. So nitrous oxide is basically one of those intermediary gas that the nitrate is basically converted to. So you find that you will get some nitrous oxide, and you will get N2, which is the normal atmospheric nitrogen that we have in the atmosphere. But we don't normally like we don't want any N2O, we don't want any nitrous oxide, because it is too harmful to the ozone layer, right? So I just wanted to explain these things, so you can have like a holistic understanding of the nitrogen cycle. So I hope you understand the whole concept of the cation and anion, and the NO3 minus being more mobile than and more susceptible to leaching, whilst also being more, the plant can also uptake it very quickly. It is more mobile than the NH4 plus, which is less mobile, right? Also understand the fact that there are many ways to add nitrogen to the soil, and so on. So of course, if there are any questions, any comments, please put them in the comments here, and please remember to subscribe to the channel. As I always say, knowledge is power, and you are only empowering yourself when you watch my videos. So until next time, please keep safe. I'll see you again in another video.